So, good morning, students. In the previous class, we have seen shear stress distribution for I sections, shear stress distribution for rectangular cross sections, and we have solved some problems on shear stress distribution for I sections and L sections. So now, in this class, we'll discuss about the shear stress distribution for a circular cross section. See students, most of the problems that appear will be on I sections, L sections, T sections only, but it is necessary for us to study about all the formulas of shear stress distribution for all the cross sections that are known. See, we majorly consider rectangular cross sections, circular cross sections, and triangular cross sections. So we'll see how shear stress is distributed across this kind of cross sections, and problems will be mostly on I sections and T sections, and there may be a chance of asking derivations for this. Okay, so in examinations there is huge chance of asking derivations of this circular cross section, triangular cross section, or for rectangular cross section. And if they go into problems will be mostly on I sections and T sections, students. So now I hope the screen is visible, right? Is the screen visible, students?
Yes, sir, visible, sir.
Okay, so let us see the figure carefully. Uh, we are about to discuss shear stress distribution for circular cross section in this class. So I have drawn a circle. I have drawn a circle of diameter D, of diameter capital D. All of you please see the figure carefully. Only if you understand how I have taken all the things, you can derive this easily. Okay, students. So this is a circle of diameter capital D and with radius capital R, and I'm considering a point at a distance of y from the neutral axis. Okay, students, have you all observed this y? So I am considering a point at a distance of y from the neutral axis, students. So this is neutral axis. This is my neutral axis, and I'm considering a point at a distance of y from the neutral axis. So I would like to find out shear stress at this point. So for finding shear stress at this point, I have shaded the region that is above the point that I have considered. Now, at the point that I have considered, I am assuming the breadth of the circle, breadth of the section B. In general, the diameter is capital D, but at the point that I have considered, I am assuming the width to be small b, and then this will become b by 2, that you all know, students. So now let us go to the derivation. So how do we derive this? So we have this formula, students. Tau is equals to Vx into Ay bar by Ib. Is it right? So we have got this formula. In this formula, what is Ay bar, students? Ay bar is area moment area moment of shaded portion. Is it right? So Ay bar represents the area moment of the shaded portion here. Now let us consider. So consider the right triangle. Consider the right angle triangle. Consider the right angle triangle shown in dashed lines. So I have represented some dashed lines in the figure, students. If you observe that, it represents a right angle triangle shown as dashed lines in figure. Dashed lines in figure. All of you please observe this dashed line, students. This appears to be a right angle triangle. Now, by using Pythagoras theorem, I can write hypotenuse square. Hypotenuse square is equals to side square plus side square. So b by 2 is 1 square, students. One side. and y is another side. Side square plus side square is equals to hypotenuse square. So I have written this. Is it clear, students? So I have written this since side square plus side square, for a right angle triangle, side square plus side square is equals to hypotenuse square. This we know. So here in this triangle, in this particular triangle, hypotenuse is capital R. So capital R square is equals to y square plus b square, that I have written. Now let us make b as subject, student. From this equation, let us make b as subject. So if you try to make b as subject, we'll get b square plus 4y square is equals to 4r square. So I have taken this 4 outside and I have multiplied this. And if you write for b square becomes 4r square minus 4y square. So let me call this as equation number 1, students. And now let us differentiate this above equation. So differentiating equation 1, differentiating equation 1. So if you differentiate equation 1, what does this become, students? B becomes 2b, okay, 2b 2b into db is equals to, r is constant, students, r is constant, so this becomes 0. So minus 8y into dy. So we'll get this. Okay. If you differentiate it on both sides, we'll get this 2b dv is equals to minus 8y dy. So let us write this y dy as subject, students. Y dy. So if you take y dy as subject, what does this equation becomes? This equation becomes minus b by 4 db. And let me call this as equation number 2. Now, after doing this, let us consider a small strip on the shaded portion. See, students, I have drawn a red color line here, So in the total shaded area, I'm just considering a small strip of thickness dy. Okay, students, small strip of thickness dy, which is standing at a distance of y from the neutral axis. So from y, the strip that I have considered is standing at a distance of, from neutral axis, the strip is standing at a distance of y. Now, if you consider that small strip, now let us write this line. Let us consider, uh, let us consider a small strip of thickness dy, of thickness dy at a distance y from neutral axis, in the shaded region. So I am considering the strip in the shaded region. Okay, so with a thickness of dy. So if you consider this thickness, and if you want to write moment of area for that considered strip, so what is moment of area, students? We have no moment of area. Moment of area in general, what is moment of area, students? Distance into area, perpendicular distance into area, or area multiplied by distance. So that is what we call it as moment of area. If it is moment of force, we multiply force with respect to distance. So here area multiplied by distance. Now let us write moment of area of considered strip about NA, can be given as see, students, area multiplied by distance from neutral axis is y, area is b multiplied by dy. Is it right, students? So dy is the thickness, b is the width. So area of that particular rectangle that we have considered will be b into dy, and distance is y. So I can write it like this, right? So moment of area can be written as b dy into y. Now keep this aside. Now if you want to write moment of area of the entire shaded region, so let us write moment of area for entire shaded region. So we know moment of area for a small strip, and I would like to write moment of area for the entire shaded region about neutral axis. Okay, students. So if I try to do this, what happens is a y bar. So I am assuming a y bar as moment of area of the entire shaded region. A y bar will be, so I can integrate this. So integral of this equation with the limits y into r gives me moment of area of the entire shaded region. Okay. So I hope you all got this equation, students. All of you listen carefully. We have got a circle like this. Okay. In this circle, we have considered this as shaded region. And in this shaded region, what I am saying is I have just considered a small strip like this, small strip of dy thickness. So I have written moment of area for this small strip. So small strip moment of area is b into dy, and it is standing at a distance of y from the neutral axis. So b into dy is area and y is distance. So I have written for small strip. So if I want moment of area for the entire region. So this is my entire region, and I have written for small strip. So this small strip, this small strip can be integrated to get moment of area for the entire shaded region. So that is what I have written here, and I have applied limits y to r is because, so this area, students, all of you see here, this is standing at y initially, and if you go on increasing this, what does this become? This will be r, right? So that is why limits applied as y to r, a y bar is equals to integral over y to r, b dy into y. Is it clear? Is it clear, students? Any difficulty here? Please let me know if you have got any difficulty here.
Yes, sir.
Kiran?
No, sir. Clear, sir.
Okay. So we have done this integral, students. Now let me rewrite this, just y to r. I'll move dy other side. Okay, d into y into dy. Okay, so from equation 2 we have, from equation 2 we have, what do we have from equation 2, students? Y dy, we have taken y dy as minus b by 4 db. So now let us substitute this minus b by 4 db in this. So this implies a y bar is equals to integral over b remains same, y dy. See, this y dy has to be replaced by this. So minus b by 4 into db. See here, students, what happened is we have removed y terms here. Y and r is gone. So the limits will change from b to 0. Okay. The limits will change from b to 0. Why? Because width at the initial stage. So this is our shaded portion. So this is our shaded portion. Width at the starting portion is b. As it moves on, as the strip moves on, what happens to b here, students? What happens to b here? B becomes 0. So the upper limit is 0 and lower limit is b. So integral over b to 0. I have changed these limits y to r are replaced by b to 0. So why I have replaced is because there is no y term here. Y term is replaced by b. So I have replaced limits from b to 0. Now let me remove this minus sign, students, so that I can change the limits upside down. So integral over 0 to b. So I am changing this limits upside down to just remove this b minus sign. So this becomes b square by 4 into db. Is it clear, students? So if you apply integration, so upper limit minus lower limit, So first is upper limit. If you substitute upper limit, and then lower limit is 0, so no need of substituting lower limit and all those things. Just integrate this. So if you integrate this, integral over b square, this implies a y bar is equals to integral over b square. What is this, students? B cubed by 3. So we have already 4 here into db. Okay, so db will be gone, no? So integration is done, so db will be gone. So since integral over b square is equals to b cubed by 3. Okay, so this implies a y bar. How much is a y bar now, students? B cubed by 12. So we got moment of area of the shaded region as b cubed by 12. Now let us write all these things in shear stress equation. So we have shear stress tau is equals to Vx into Ay bar by Ib. Is it right, students? So we have got this equation. So if you substitute Ay bar in this equation, what happens? Vx into b cube by 12 by I. What is I, students? So let me write IB only here, and this becomes Vx into b square. So b gets cancelled and square remains, and 12 goes down. So 12I. Now let us write I value for triangular, I value for circular cross section. What is I for circular cross section, students? I for circular cross section. Not remembered? So this implies tau is equals to, what is b, students? We have derived b square in equation 1. From this equation 1, we can write Vx into r square minus y square by 12I. So since equation 1 gives us b square is equals to 4 into r square minus y square. Equation 1 lo derive cheskunnam manam idi. B square is equals to 4 into r square y square. I have just substituted that. Now this becomes 4 and 12 gets cancels, and this becomes Vx into r square minus y square by 3I. Is it right? Now let us take this equation in terms of d. Okay, we have this equation in terms of r. Let us reduce this equation into d. So we know that r, capital R, is equals to d by 2. So radius is equals to diameter by 2, and I for circular cross sections. Moment of inertia for circular cross sections, no one has yet said. What is moment of inertia for circular cross section, students? We have discussed this earlier also.
Pi by 16, capital D square minus small d square.
Pi d power 4 by 64. Pi d power 4 by 64. This is circular solid section. Funny, what we have said is for hollow section, d square minus d square. That is all for hollow section. This is circular solid. I'm just considering circular cross section. Okay. So I will be pi d power 4 by 64. Now let us substitute these two equations, these two values in tau. So this becomes Vx. R value is d by 2. So I'll just take it as d square by 4 minus y square remains same, and 3 multiplied by pi d power 4 by 64. And this is the equation for tau of circular cross section at any point in the circular cross section. See, students, if you consider a circular cross section like this, and this be the neutral axis, at any point if you want to find out, okay, this will be the equation. So here Vx will be given. Vx is shear force, and d square, d is nothing but diameter of this circle considered. Y is the position of the point that we have considered from the neutral axis. Okay, students. So here y represents position of the point from the neutral axis that we have considered. Okay, so this should be noted, and this is what we have got now. Now if you want to know where it is maximum, so if you observe the equation carefully, students, if you observe it carefully, so if y is equals to 0, this equation becomes maximum. So from the above we can say that from above we can directly say that tau is maximum at y is equal to 0. So if you substitute y is equals to 0, tau max, what does tau max become, students? Tau max is equal to Vx into d square by 4 by 3 into pi d power 4 by 64. So this can also be rewritten as just 4 by 3 Vx by pi d square by 4. Is it clear, students? I can replace it like this, right? Hope it is okay for everyone. Is it okay, guys? I have just simplified the above equation, this equation, and then I have written this as 4 by 3 into Vx into pi d square by 4. So 4. Okay. Now let us see what is tau average. Tau average, we know that force by area. So stress is nothing but force by area. So what is force, students? Force is nothing but Vx. Area of the circle is pi d square by 4. Okay. Area of circle is pi d square by 4. So this is nothing but here. So we can write tau max is equals to tau max is equals to 4 by 3 of tau average. Is it clear? So this is very important for your competitive exams. This is very important for competitive exams, students. So for rectangular, this is for circular cross sections. For rectangular cross sections also we have derived. For rectangular, what is it? Tau max is equals to 3 by 2 of tau average. For rectangle, this is for rectangle. Okay. Do you remember this, students?
Yes, sir.
Okay. So this relation is very important, and there are chances of asking this kind of derivation also. And if you get problems, you can directly solve. There is no complexity if you get a problem.
సార్ దీంట్లో ఎక్స్ట్రీమ్ ఫైబర్ ఉండదా సార్?
ఎక్స్ట్రీమ్ ఫైబర్ ఉంటుందన్న ఎక్స్ట్రీమ్ ఫైబర్ ఇదే కదా ఇంకా ఇదే ఈ పాయింట్ జీరోనే ఆబ్వియస్గా. సో ఇఫ్ యూ వాంట్ టు డ్రా ఇట్ నౌ, so at y is equals to 0, it is maximum. Y will be 0 at neutral axis only. So y is 0 at neutral axis only, and this will be a parabola only. So this will be a parabola only. This is tau max. It is not that for every cross section it will be at neutral axis. Tau max will be at neutral axis only for rectangles, I sections, and circular sections. So that will also come to that. Okay. So దీంట్లో కూడా ఈ ఎక్స్ట్రీమ్ ఫైబర్స్ ఉంటాయి. పని ఇప్పుడు సర్క్యులర్ క్రాస్ సెక్షన్ అంటే వీ హ్యావ్ కన్సిడర్డ్ దిస్, రైట్? Okay, this is what our circular beam looks like. So here also the extreme fibers remain. The extreme fibers, it is 0. Okay, we are just considering, we are calculating this shear stress distribution at cross sections. So if you cut it here and if you see the cross section here, there will be circular cross section, and in this circular cross section I am solving shear stress distribution. So it applies for this also, it applies for this, and it also applies for this. Only thing is Vx changes from here to here. So Vx is different. So at this particular cross section, what is Vx? That will be given in the problems. Okay. So for circular cross sections also at extreme fibers, shear stress is 0. Is it clear?
Yes, sir.
Okay. So now so let us go for triangular cross sections. See students, shear stress distribution for triangular cross section. We'll finish this off, okay? See, for cross sections with no parallel sides, cross sections with no parallel sides in the sense, if you consider a triangle, if you consider a triangle, if you consider a triangle like this, students, so this has no parallel sides. అంటే ఇట్లా రెక్టాంగిల్ ఉన్నట్టు ఇప్పుడు రెక్టాంగిల్ చూసుకుంటే దిస్ ఇస్ ఎ ప్యారల్ సైడ్ అండ్ దిస్ ఇస్ ఎ ప్యారల్ సైడ్. సో ఫర్ రెక్టాంగిల్ అండ్ ఫర్ ఐ సెక్షన్స్ విల్ బి హ్యావింగ్ ప్యారల్ సైడ్స్, రైట్? సో ప్యారల్ సైడ్స్ అంటే ఇక్కడ ఒక సైడ్ ఈ సైడ్ ప్యారల్ ఉంటుంది, లేకపోతే ఈ సైడ్ ప్యారల్ ఉంటుంది. సో ఫర్ క్రాస్ సెక్షన్స్ విచ్ హ్యావ్ ప్యారల్ సైడ్స్ విల్ గెట్ షియర్ స్ట్రెస్ మాక్సిమం అట్ ద న్యూట్రల్ యాక్సిస్. న్యూట్రల్ యాక్సిస్ దగ్గర వీటికి టౌ మ్యాక్స్ ఉంటుంది. అంటే రెక్టాంగిల్కి, ఫర్ రెక్టాంగిల్, ఫర్ ఐ సెక్షన్ అండ్ ఫర్ circular cross sections at neutral axis will get tau as maximum. But for triangles it will not be maximum at neutral axis. For triangles, for rhombus like this, rhombus, okay, there are no parallel sides. So for rhombus and then for hexagon, this kind of cross sections, there will be change of position of tau max. Tau max will be different, okay? So let us see how this becomes. So for triangular cross section, students, let us draw a triangle. Let us draw a triangle. Okay. Okay. So let us consider a triangle and let this neutral axis, let this be neutral axis. So for triangle, we know that neutral axis position will be at a distance of see, this is h. Okay, let us consider this as h, capital H. Okay, capital H, and this is neutral axis. So we know that neutral axis lies at a distance of 2h/3 from top. So from top it will be lying at a distance of 2h/3, and from base it will be lying at a distance of h/3. Okay, h/3. So we know this, and this is neutral axis. And let us consider a triangle. Let us consider a point where we would like to measure shear stress. So I am taking point at this position, students. So I'll shade all this portion. Okay, I'll shade all this portion, and I just consider this length as b, small b, and this is capital B. Okay, let us take this as capital B. And if you draw the neutral axis for this small triangle that we have considered, it will be like this. And let this height, entire height, be small h, small h. Okay, so that the neutral axis position will be at a distance of 2h/3 from top and h/3 from bottom. Is it clear, students? I hope everyone are okay with this figure. So only if you understand.
ఈక్వల్ అవుతుంది కదా సార్ అక్కడ
ఏందన్నా హెచ్?
క్యాపిటల్ హెచ్ పెట్టినారు కదా సార్ అక్కడ స్మాల్ ట్రయాంగిల్ కి.
ఓకే ఓకే, సారీ స్మాల్ హెచ్ కదా. ఓకే, 2h/3 and this is h/3. Okay, okay, everyone okay with this, right? Otherwise let us consider this as y. Okay, let us not make this all confusion. All of you see here, students, let us consider this height to be y, and this becomes 2y/3 and this becomes y/3. Okay, is it okay now, Kiran?
ఓకే సార్.
So now if you all understand this problem, if you all understand how this triangle is being run, we can easily solve this. So there is a triangle of base capital B and height capital H, and in that triangle we have drawn neutral axis, and we know that the neutral axis position for a triangle will lie at these distances. From top it is 2h by 3 and from base it is h by 3. And in this triangle I would like to find out shear stress at this particular point. Okay, at this particular point, and I'm assuming a triangle over the shaded region, and for that also I have drawn a neutral axis, and I am assuming the height of the considered shaded region as y and width be b. Now we know that, so from the figure, by using similar triangles we can write that capital B by small b is equals to capital H by small y. Is it right? Can we write this by using similar triangles? So this can be written as small b is equals to b by h into y by similar triangles. So by similar triangles corollary, see here, this shaded region is one triangle and the entire one is another triangle. These two are similar. So I have taken this equation, base by base is equals to height by height. So from that I have derived small b. Now we know that tau is equals to Vx into Ay bar by Ib. So here b is nothing but Bh by, see here students, b is capital Bh by y. So this we have just now derived, and A is nothing but area of shaded region. Area of shaded region, students. So area of shaded region becomes half into b into y, half bh gada. So b is base and y is h. Now substitute this b is equals to capital B by capital H into y in this area, so that this area becomes half into b place lo b by h into y and substitute chesta appudu y square aitadadi. Okay, so this implies area is equals to half into b by h into y square. Okay students, so now let us keep this aside. So what is y bar, students? Y bar is distance of centroidal axis of shaded region to neutral axis of section. Is it right? This is what y bar is. So y bar ante entidante ikkada chudandi. So this is neutral axis of the shaded region, this is neutral axis of the entire section. This part is nothing but y bar. So if you want to write y bar, what I'll do is, so I'll subtract 2y by 3 from this 2h by 3. So from this total 2h by 3, I'll subtract 2y by 3. Is it right? So that I'll get this distance. Is it right? Everyone okay with this?
Okay, sir.
So now y bar can be written as 2h by 3 minus 2y by 3. So this becomes 2 by 3 of h minus y. Now moment of inertia for triangular cross section, students. I is nothing but moment of inertia of section, entire section. This is for entire section, entire triangular section. So moment of inertia for triangular cross section is bh cubed by 16. Sorry, bh cubed by 36. Okay, bh cubed by 36. So now let us substitute all these values in tau. So tau becomes Vx into half into b by h into y square into 2 by 3 of h minus y by, so moment of inertia is bh cubed by 36 into b by h into y. So this is b. So this equation, if you simplify this equation, students, so 2 gets cancelled, 3 ones are 3 12s are, this gets cancelled, and you can cancel this b by h and this b by h, and then this y square goes to this y, and so if you simplify this will happen, students. So 12 into vx into hy minus y square. So just y ni lopal తీసుకొచ్చినాడు, hy అయింది, h multiplied by y minus y into y square అయింది by this bh cube remains. Okay, so this is what we have got. Now what can we write from this, students? Moment of area of the considered strip. Sorry. So tau is equals to, we can write this, students. Tau is equals to 12 Vx into Hy minus y square by Bh cubed. Okay, so this is for triangular cross section. So if you write a triangular cross section, if you get a triangular cross section like this, and if you want to find out at certain point, so you just make this as a triangle and find out this height. If you know this height, you can directly find shear stress at this point. So that equation is 12 into Vx. Capital H is height of this entire triangle. So this is capital H, students. So y is height of the small triangle, and b we know base, this base. Okay, so this is what the equation for this. Now here, if you observe the equation carefully, students, in the previous derivations, what we have done is we have taken at y is equals to 0, it is maximum అని చెప్పి రాసేసుకున్నాం. ఎందుకు రాసుకున్నాం అంటే అక్కడ ఈక్వేషన్ is very clear there. So there is only one y there. So if you see the circle equation, students, I am just rewriting the circle equation. D square by 4 minus y square by 3 into pi d power 4 by 64. This is what we have got for circle. So here, if you observe this equation carefully, there is only one y term here, and this is the only variable here. అంతే కదా, ఇది మాత్రమే వేరీ అవుతుంది క్రాస్ సెక్షన్ లో. ఇప్పుడు సర్క్యులర్ క్రాస్ సెక్షన్ డ్రా చేస్తే y అనేది మాత్రమే వేరీ అవుతుంది. అంటే ఒకసారి ఇక్కడ కనుక్కుంటా, ఒకసారి ఇక్కడ కనుక్కుంటా షియర్ స్ట్రెస్, ఒకసారి ఇక్కడ కనుక్కుంటా. సో y వేరీస్. But if you observe remaining terms, d in the diameter of the circle, does this change, students? No. Vx, shear force at this cross section, that will also not change. So these are all constants here. Only y is variable. So that is why what I have taken is at y is equal to 0. ఇప్పుడు y అనే టర్మ్ ని లేకుండా చేస్తే ఇక్కడ y మాత్రమే వేరియబుల్. y ప్లేస్ లో నేను 1 సబ్స్టిట్యూట్ చేసిన, ఎనీథింగ్ అదర్ దాన్ 0 సబ్స్టిట్యూట్ చేస్తే this value will be less. Okay, if I substitute 0, this value becomes max. By using this equation, we can directly say that for circular, for rectangular cross sections, we can directly say that if you substitute y is equal to 0, that becomes 0. That becomes maximum. అని చెప్తాం మనం సర్కిల్ కి ఇంకో దానికైతే. కానీ if you observe this triangle equation, students, all of you carefully see this triangle equation. There are two y terms here. So hy minus y square, we cannot simplify this, and the variable is attached to another constant value. So h is constant, but the variable is linked to this constant value here. So for this, to find maximum of this equation, ఈ ఈక్వేషన్ ని maximum కనుక్కోవాలంటే we have to differentiate this tau with respect to y. So differentiate tau with y. So what I mean to say is, let us write d tau by dy as 0. So if you write this and find out y value, there it becomes maximum. Okay, so if you find this by using this, find y. Okay, so I just write this equation. So what I mean to say is d by dy of 12 into Vx into Hy minus y square by Bh cubed. Okay, so this should be equated to 0. So if you equate it to 0 and try to resolve this, students. So if you try to resolve this, 12 is constant, Vx is constant, Bh cubed is constant. So derivation for constant will be 0. So they can directly write it as d by dy of Hy minus y square is equal to 0. This implies, what does this imply, students? H minus, so d by dy of Hy becomes h, y square 2y, so h minus 2y is equal to 0. This implies y is equals to h by 2. This shows that at y is equals to h by 2, tau is maximum. Okay, students. So now for getting tau max, substitute y place లో h/2 substitute చేద్దాం. So h into h/2 minus h square by 4 by bh cube. So if you substitute this and try to simplify this equation, students, I'll just simplify this equation. So here this becomes h square by 2 minus h square by 4, which is equals to h square by 2. So this will be simplified as 12vx into h square by 4 by bh cube. If you further simplify this, students, so h and h square and h cubed will go. So tau max will be 3 into vx by bh. So this will remain for us, students. Okay, is it clear? So tau max for triangular cross section is 3 into vx by bh. So if you see here in triangular cross section, tau max, so this is at h by 3. So at h by 2 from the base, we are getting tau max. Okay, so this is tau max. This is tau mean. Okay, so for triangular cross section, it differs from the neutral axis. For rectangular cross sections, for I sections, for circular cross sections, we have got tau maximum at neutral axis, but triangular cross section, it differs. Is it clear? This you should make a note of this. This is very important for competitive examinations. So now let us write for tau average, students. What is tau average? Tau average is nothing but force by area. So what is force, students? Vx. Area is half bh, half into base into height. So this can be written as 2 into vx by bh. So I have just replaced this 2 to the numerator. Now what will be tau max in terms of tau average? So tau max can be written as just multiply and divided by 2, 3vx by bh. Okay, ఇది మన tau max గానా? Tau max ఎంత ఉంది? 3vx by bh. So 3vx by bh అని రాసిన. జస్ట్ ముందర 2 తోని మల్టిప్లై చేసి డివైడ్ చేసిన. This does not mean anything. So this has no significance. Just multiply and divided by 2. సో ఇది మల్టిప్లై డివైడెడ్ బై 2 చేస్తే ఏమవుతుందంటే 3/2 పక్కకు తీసుకురండి. జస్ట్ 3/2 2vx by bh అని రాద్దాం. సో 2vx by bh is nothing but tau average. So tau max is nothing but 3/2 of tau average. So this is also very important, students. So these two things and where maximum comes, ఈ థింగ్స్ రెక్టాంగులర్ క్రాస్ సెక్షన్ కి, ట్రయాంగులర్ క్రాస్ సెక్షన్ కి, సర్కులర్ క్రాస్ సెక్షన్స్ కి మీరు గుర్తు పెట్టుకోగలిగితే కాంపిటేటివ్ ఎగ్జామ్స్ లో ఖచ్చితంగా 2 క్వశ్చన్లు వస్తాయి. ఫర్ గేట్ ఆర్ ఐఏఎస్ వాట్ ఎవర్, you will definitely get 2 to 3 questions on this. So shear stress is maximum at neutral axis for circular cross sections, I sections and rectangular cross sections, and is maximum at a distance of h/2 for triangular cross sections, and for all the cross sections at the top fibers, extreme top fiber and extreme bottom fiber, the shear stress is 0. These are the points that you have to remember, and this tau max relation with respect to tau average is also very important, students. For rectangular and triangular cross sections, tau max will be equals to 3/2 of tau average. For circular cross sections, it is 4/3 of tau average. So if you remember this is for circular cross sections. If you remember this relation, you can solve some problems in competitive examinations. Okay, I hope it is clear, students. Everyone okay with this, right? Any doubts, students? So there is one more small thing that we have to do, students. So let us shear stress at neutral axis for triangular cross section. So for triangular cross section at neutral axis కనుక్కుందాం. అప్పుడు ఏమైతుంది? y is equals to 2h/3 అవుతుంది, అంతే కదా? So y is 2h/3. So if you substitute tau is equals to tau na, so 12vx into h into 2h/3 minus 2h/3 whole square by bh cube. And if you simplify this equation, students, if you simplify this, you'll get 24vx by 9bh. So So this can also be simplified as 8Vx by 3BH. సో ఈ ఈక్వేషన్ కూడా మీరు గుర్తుపెట్టుకోగలిగితే at neutral axis for triangular cross section, tau at neutral axis for triangle. So 8Vx into 8Vx by 3BH. So this is what all about shear stress, students. If you have got any doubts, please let me know, students. You can also text.
సార్ సర్క్యులర్ సెక్షన్ ది ఒకసారి చూస్తారా, స్క్రీన్ షాట్ తీసుకుంటా సార్.
Circular cross section derivation, huh?
ఎస్ సార్.
Final derivation, huh?
సార్ లేదు సార్, స్టార్టింగ్ సార్.
Okay, image తీసుకుంటారా?
ఎస్
I will share these notes, okay?
ఎస్ సార్.
You can also take screenshot. Meanwhile, I will also share this. Students, I have shared an assignment with you. Have you seen this? Have you seen assignment, students?
4 sets ఏమున్నాయి సార్?